now that we've done a full example of going through and doing a confidence interval, let's discuss a little bit more of why I may choose a certain level of confidence. If you recall, we drew this general picture to sort of understand what a confidence interval would do. And this 1 minus alpha that we had here was our probability that that proportion of the population would be somewhere inside my interval, versus that alpha, or that leftover piece, was the probability my interval would not contain p. So we discussed very briefly that we would like this to be a larger proportion, and then this to be a smaller proportion. So a question that many of us then may ask is, why don't we just always then use this 99% confidence? Why don't we use something else? Well, let's talk about again how that confidence affects our interval. So looking at our formula, the only place I use that confidence level is determining my z-score. And just as I saw on that chart, I'm going to have a different z based upon my different confidence level. And as you can see, as my confidence level increases, so does the z, which should make sense. The more confident I want to be, the more standard deviations I've got to go out in order to capture that percentage. So what that also means is, how does it affect me mathematically? So if I look at our example that we went through, we had a 90% confidence level. That made my z 1.645. If instead I changed it to be 95% confidence, that's going to then change my z to just simply be 1.96. So what effect does that have on our calculation? Well, if this were to become 1.96, it's going to start having an effect about right here when I do that multiplication. That standard error would not change, but as soon as I take 1.96 times 0.0185, that's going to give me a different margin of error down here. More specifically, it's going to give me a larger margin of error, which, just thinking through my picture I had here as well, means that my interval is going to have to go out further. I'm going to have a wider interval to capture a larger proportion. So what that means for looking at our example here is, if I want higher confidence, that's going to give me a wider confidence interval, versus a lower level of confidence will give me a narrower confidence interval. Now, why do I really even care about the width of my interval? Well, let's go through an example and determine which of my intervals I give you here is more useful. Suppose you are interested in figuring out the percentage of NKU students who are male. And I could give you one of the following two results. I could say it's somewhere between 10% and 80% of all NKU students are male. Or I could come back and say that somewhere between 38.8% and 51.2% of the NKU students are male. Now, which one of those intervals is more useful? Well, if I look at that first interval, that really doesn't help me very much. Even without going out and collecting any data, I could probably tell you that somewhere between 10% and 80% of NKU students are male. That covers a lot of values. Versus the second one, this gives me a lot more information that I did not already have. So this second one, being a narrower interval, gives me more information. So I have a much better idea of what that actual value is, because it's narrowed it down for us. So then, how can I make a narrower interval? Well, the first one is obvious. I can lower my level of confidence. Well, but if I lower level my confidence, right now that chance of me having the correct value somewhere inside my interval has decreased, right? My interval has a much less chance of capturing that true proportion. So even though I get a narrower interval, I'm less confident in my answer. Something else I could do, though, instead, is take a larger sample. Well, how does that have an effect on our interval? Well, first, if we just look at the formula, where does sample size show up? Well, it shows up right here in that standard error piece. And more specifically, it's on the bottom of that standard error. So if I increase my n, I'm actually going to decrease my standard error. So for example, I would see that this 0.018525 would be a smaller number if I replaced 600 with anything larger than 600. If my standard error gets smaller, that also means that my margin of error is going to get smaller. So those are my two different ways that I can make my interval narrower, is to either lower my level of confidence, which of course, hopefully we see the downfall in that, or I can increase my sample size. Now, how big of a sample might I need? That is a question we will answer in a future video in this module.